Hi, my name is Abdulaziz Wicket, and I'll be with you through this presentation over the subject of Flight Computer Model E6B. The E6B Flight Computer is widely used in the aviation community. It is a well-designed mechanical calculator, accurate in result, yet simple to operate. It needs a common sense, and the more the practice, the easier it is. The E6B Flight Computer has two sides in back of each other: the calculator side and the wind side. In general, the calculator side is used for speed, time, distance calculation, fuel calculation, true airspeed calculation, off-course calculation, altitude calculation, general calculation, and unit conversion. Where the wind side is used to calculate ground speed, true heading, wind effect on the aircraft, and to figure out the unknown wind. The calculator side of the flight computer E6B consists of the following: an outer fixed non-rotating scale on the computer side, normally used to figure out fuel consumption, miles, gallons, and aircraft through airspeed. The inner scale, another scale on the inner scale, which represents hours and minutes only. Three noticeable indexes are clearly marked on the calculator side. First one is a unit index in the shape of figure 10 on the outer non-rotating scale. Second one is another figure 10 unit index on the inner rotating scale. Third one is the speed index in the shape of triangular on the inner rotating scale pointing outward. Also, three windows could be seen on the inside rotating scale. First one is the true airspeed and density altitude window. Second is the density altitude window. Third is the altitude comparison window. Also on the outside, last but not least, a temperature conversion scale. Also, a printed unit of measurement could be seen on both scales, some with pointing arrows and some with no arrows. Moving clockwise, imperial gallon conversion arrow on the outside non-rotating scale, another imperial gallon conversion arrow on the inside, kilometer arrow on the outside non-rotating scale, kilometer arrow in the inside, US gallon arrow on the outside, US gallon arrow on the inside rotating scale, feet arrow on the outside non-rotating scale, kilogram arrow on the inside rotating scale, true airspeed marking on the outside non-rotating scale, calibrated airspeed marking on the inside rotating scale, pounds arrow on the outside non-rotating scale, seconds arrow on the inside rotating scale, meters arrow on the inside rotating scale, liters arrow on the outside, another liter conversion arrow on the inside, a true altitude marking on the outside non-rotating scale, calibrated altitude marking on the inside rotating scale, fuel marking on the outside non-rotating scale, distance marking on the outside non-rotating scale next to two arrows representing nautical and statical miles. Statical marking on the inside rotating scale, a fuel pound arrow on the outside non-rotating scale, oil pound arrow on the outside non-rotating scale. Note: when the two indexes are aligned together, unit of measurement are retained to their original value. Example: 1 imperial gallon equals 1 imperial gallon, or 1 kilometer equals to 1 kilometer, or base unit for time measurement is 60. Scaling: when using one or all the scales, a common sense must be used to maintain the same value of numbers, where one figure could be used for more than one value. For instance, 10 could be used for 0.1, 1, 10, 100, 1000, and so on. And 90 on the outside scale, for instance, could be used as 0.9, or 9, or 90, 900, 9,000, and so on. And this applies the same for the time scale. For instance, 55 could be read as 55 seconds, 55 minutes, 55 hours. Note: on the inner scale, between figure 15 and figure 25, Increments between two values are increments of 2. Example: 0.2, 2, 20, 200, 2000, and so on.